If you flip a coin 100 times and count the number of heads, you do not doubt that the coin is fair if you observe exactly 50 heads. However, you might be somewhat skeptical that the coin is fair if you observe 40 or 60 heads. You'd be more skeptical that the coin is fair if you observe 37 or 63 heads, and highly skeptical that the coin is fair if you observe 15 or 85 heads. In this situation, the greater the difference between the number of heads and tails, the more evidence you have that the coin is not fair. Statisticians refer to the difference between the observed statistic and the hypothesized value as the effect size. A p-value measures the probability of observing a value as extreme as the one observed or more extreme. For example, if your null hypothesis is that the coin is fair and you observe 55 heads and 45 tails, the p-value is the probability of observing a difference in the number of heads and tails of 10 or more from a fair coin tossed 100 times. If the p-value is large, you would often see a difference this large in experiments with a fair coin. If the p-value is small, however, you would rarely see differences this large with a fair coin. In the latter situation, you have evidence that the coin is not fair. A large p-value indicates a high probability of observing your results, or more extreme results, given that the null hypothesis is true. So, it is reasonable to assume that the null hypothesis is true. A small p-value indicates a low probability of observing your results, or more extreme results, given that the null hypothesis is true. So it is no longer reasonable to assume that the null hypothesis is true. So the p-value is used to determine statistical significance. It helps you assess whether you should reject the null hypothesis. A p-value is not only affected by the effect size, in this example the observed proportion of heads. It is also affected by the sample size, here the number of coin flips. For a fair coin, you'd expect 50% of the flips to turn up heads. Let's say that you flip the coin 10 times and observe 4 heads. In this example, the proportion of heads is 0.4. This value is different from the 0.5 you'd expect according to the null hypothesis. The evidence becomes stronger as the number of trials on which the proportion is based becomes greater. As you saw in the section on confidence intervals, the variability around a mean estimate gets smaller as the sample size gets larger. For larger sample sizes, you can measure means more precisely. Therefore, 40% heads out of 400 flips makes you more sure that this was not just a chance difference from 50%, than 40% out of 10 flips. The smaller p-values reflect this confidence. The p-value here assesses the probability that this difference from 50% occurred purely by chance.